So this is the numerical. We are going to solve this by the relative velocity and acceleration method. Relative velocity and acceleration method. Now, for the given example, you have to redraw this given figure. And this redrawn figure is called as space diagram. All dimensions are known to you. You have to observe the minimum dimension and maximum dimension. By knowing the minimum and maximum dimension, you have to select your scale, and this diagram we are calling as a what? Space diagram. So you have to select the appropriate scale for this. 1 centimeter equal to 1 centimeter equal. So you have to draw the space diagram. You have to select the appropriate scale for this. These are the dimensions. Minimum dimension is 180 mm and maximum one is 550. So by seeing this minimum and maximum dimension, you have to select your appropriate scale for the space diagram. Right? What scale we will suggest? 60 mm. So this is my scale. Now by using this scale, you have to draw this space diagram. Now where to begin to draw the space diagram? कहाँ पे चालू करना है space diagram निकालने को? Always remember, locate the fixed point first. To begin with the space diagram, जो भी fixed point है मेरे space diagram में, वहाँ से चालू करो. Locate this point in your space O. Then take 105 distance, horizontal 105 distance, and vertical 300 mm. By your scale, locate this second fixed point. What I am doing? I am locating the fixed point first. I am locating the fixed point. Horizontal distance of this two fixed point is 105. Vertical distance is 300. I have located these two fixed points. Go to this upper fixed point. This is the O point. Measure the 45-degree angle. At 45 degree, draw one front line. Draw one front line. Now, as per your dimension of OA, by your scale 3 centimeter in your compass, if the compass at O, cut this front line, you will get the A point. You will get the A point. Now make this OA darker. Make this OA darker. I got the OA. I got the OA. Now I know the distance of AB. AB equal to how much? 360. By my scale, it is 6 centimeter. It is 6 centimeter. If the take the 6 centimeter distance in your compass, if the compass at A, draw one arc here. Draw one arc. By keeping the compass at A, I have drawn the arc. With the 360 distance by scale, I have drawn one arc by keeping the compass at A. Right? Now come to the second fixed point. I know the distance CB. CB equal to how much? 240. By my scale, it is 4 centimeter. Take the 4 centimeter distance in your compass. Keep the compass here at the C. C point already located, no? So keep the compass at C and cut this arc. Previous arc. Previous arc means the arc which you have drawn from the A for 360 mm. Yes or no? So the previous arc will get cut here, and that cutting point will be the B. That cutting point will be the B. You got the B? Now you know the BD distance. How much BD? 540. By your scale, take that much centimeter. 9 centimeter in your compass. Keep the compass at B, and this horizontal line you have to cut. Cut this horizontal line. There you will have the slider D. Join this B with the D. In this way your space diagram will get completed. Right? So this is the complete space diagram. Now after drawing this space diagram, after completing this space diagram, to begin with the velocity polygon, at least for any one link, mostly first link, which is the crank. For that link, you must know the speed. Or in some numerical, they will provide directly omega of that link. Omega of that link or speed of that link. Are you getting? Omega is angular velocity, that is 2 pi n divided by 60. So they have provided in this case the speed of the crank is 180. By knowing the speed of crank, I can easily find out the omega of crank. Omega equal to 2 pi NAO divided by 60. 2 multiplied by pi multiplied by 180 divided by 60. So omega AO equal to how much? 18.84. It is radian per second. Radian per second. Now once you know the omega, once you got the omega, you have to find out what? Velocity. Velocity of AO equal to omega AO multiplied by AO length in meter. AO length in meter. If you multiply that link length with the omega of that link, you will get the linear velocity. You will get the linear velocity. So omega of AO is 18.84 multiplied by AO length is 180 mm, means in meter it is 0.18. It is 0.18. So how much? So we are getting velocity of AO equal to 3.39 meter per second. Meter per second. This is the one part, because I have to start with the velocity polygon. To start with the velocity polygon, for first link, which is the crank, I must know the velocity magnitude, as well as I must know the direction of rotation. I must know what direction of rotation. This is the first part. Any doubt up to this? So I am going to start with the velocity polygon. Now I have the velocity of the crank, that is 3.39 meter per second, linear velocity of crank 3.39 meter per second, and I know the direction of rotation. I know the direction of rotation. I know the direction of rotation. So I can easily start my velocity polygon here. So in your space, before starting this velocity polygon, you have to take appropriate scale for this. Yes or no? Because the magnitude of crank velocity is 3.39 meter per second. I cannot draw the line of meter per second. Yes or no? So I have to convert this meter per second into centimeter. That's why I have to take the scale. Yes. So my scale is 1 centimeter equal to 1 meter per second. That scale I will take here. Any doubt up to this? Any doubt? So this is beginning of the velocity polygon. In your space, locate the pole. Locate the pole. Poles are the fixed positions from your space diagram. All fixed points in your space diagram are located by the single point, and that single point is called as a pole. Which are the fixed points? O, small case, then small case C. This slider. So two fixed points, I have located that by the single point O and C. Now first link of which direction of rotation is known. First link of which magnitude is also known. And for by knowing the value of velocity of that first link, you have taken your scale. Now draw the velocity vector for first link. This is the first link, OA. OA is the first link. How it is rotating? Anti-clockwise. So where will be the velocity vector goes? Up or down? Up. How the velocity vector for any link? It is the perpendicular line. It is the, so to this OA, I am going to draw a perpendicular line in the upward direction. Because OA is this link, the velocity vector for this will be perpendicular line in the direction of rotation. In the direction of rotation. Getting me or not? So this perpendicular I have drawn here. Ask the question to yourself, from where I have to draw that perpendicular line in velocity polygon. Either O or A should be here. Which is available? O is available. From O you have to draw the perpendicular line in the upward direction. This is the perpendicular vector to whom? OA. Getting me or not? समझ रहे कि नहीं? So this how कितना लंबा निकालना है ये भी आपको क्वेश्चन पूछना है. How much long it will be? Magnitude जितना. Magnitude 3.39. I cannot draw meter per second line, but I have taken the scale. Convert this meter per second into centimeter. That centimeter line which is perpendicular to OA you have to draw here. Got it? Yes or no? Everybody? So this is the first point, and this point I will call A. Immediately arrow towards A, because this O is fixed point. This is the velocity of what? A. I can write, if any point is fixed, I can draw the movable point only. Or otherwise you can also write VA or VAO. Like this also you can write. Are you getting me? The velocity vector of first link is what? Which is the second link? AB. What is the velocity vector for AB? A perpendicular line, no? Yes or no? A perpendicular line to this link will use the velocity vector for that link. So perpendicular line to OA, AB will be like this, no? Yes or no? And this perpendicular line I have to draw here. But from where? To whom you are drawing the perpendicular line? AB. Either A or B should be available. Which is available? A. Means this perpendicular line to AB I have to draw in this figure. Perpendicular इसको निकालना है, यहाँ पे निकालना है. But from where? Either A or B should be available. Which is available? A. Means this perpendicular line to AB I have to draw from this A, which is the faint line, which is the, because I don't know the direction of rotation of that link. I don't know the magnitude of that link. So I have drawn one faint line. After we will get that, where it will get cut. So after completing this AB, go to this next link. Don't go for the BD. BD link में दोनों point movable है. ये इजी जाएगा. ये fix already you got this CB में का एक point मिला आपको. मिला क्या नहीं? So I will go for the CB. What is the velocity vector for CB? Perpendicular line. But this perpendicular line I have to draw in this diagram. Yes or no? From where? किसको निकाल रहे हैं आप? C और B को. From where? C or B should be available. Which is available? C is available. So draw the perpendicular line to CB from where? From? अब ये ठीक है. इसको perpendicular line ये बाहर वाले साइड में कट कर रहा है ओरिजिनल फिगर में. So this is the perpendicular line to what? CB. Actual जब निकालते हो perpendicular निकालते you will get the real figure. Now in this case both lines looks parallel. So ये एक दूसरे को ओवरलैप करने ऐसा perpendicular दिखेगा आपको, लेकिन ऐसा नहीं आ रहा है. I have drawn it. So the line comes here. Now this is the perpendicular line to what? CB. Now this CB cut the previous perpendicular line. Yes or no? So previous perpendicular line I have drawn faint. Yes or no? It will get cut here. And so that point will be what? B. That point will be B. Now make it dark. Make it dark. This is perpendicular to what? This line is perpendicular to what? CB. So this is velocity of what? B. B. C is fixed point, no? So velocity of B. This will be if somebody showing the arrow towards the B. This is the velocity of B with respect to A. Somebody will show the arrow in this direction. That is the velocity of A with respect to B. So up to this I have finished. Then what next? Which link? BD. What is the velocity vector for BD? A perpendicular line. But this perpendicular line I have to draw there. I have to draw there. From where? B or D should be there. Which is available? B is available. So this perpendicular line to BD I have to draw from the B. So this is the perpendicular line to BD. Faint line. When it will get cut, I will make it dark. This is perpendicular to what? BD. Why I have drawn from the B? Because BD को perpendicular B और D में से जो available था उसमें से perpendicular निकल दिया. Yes or no? Then last, what is there? Slider. Slider. What is the velocity vector for slider? A parallel line to the line of flow. How slider is sliding in this case? This slider is sliding in horizontal manner. So velocity vector for this slider is a horizontal line which is drawn from the pole. Which is drawn from the, what is your pole? OC, no? So I will draw this horizontal line which shows the velocity vector of slider. Velocity vector of slider. This velocity vector of slider will cut the previous perpendicular line. Yes or no? And this point will be the D. Arrow toward D. This is the velocity of D, slider. This vector, arrow toward the D, velocity of D with respect to B. This is the velocity polygon for this mechanism. In this numerical, they have mentioned 50 radian per second square is the increasing speed of crank. So crank is not rotating at the uniform speed. So the crank in this case will have two components of acceleration. That is radial component of acceleration, which is also called as centripetal component of acceleration, and second component of acceleration is tangential component of acceleration. What I said in the classroom, I said that if your crank is rotating with uniform or constant speed, it will have only one component of acceleration. Otherwise means if the crank speed is increasing, then it is not uniform, no? So it will got the two components of acceleration. So this is the case where your crank will have the two components of acceleration. Two components of acceleration. So before going to the acceleration diagram, what you have to do? You have to prepare this table. All the links you have to note in first column. All the lengths in meter you have to note down in the second column. Third column is velocity in meter per second. As you already have drawn the velocity polygon, all velocity magnitude will get from here. So you have to complete this. All the figures are available with me. मुझे बोलो एक एक. So velocity of OA. 3 point. We have calculated it. Yes. AD. 0.95. CV. 2.8. BD. 2.4. And slider 2.1. Now somebody may be in question how these values I have written in meter per second. Velocity column में ये value कहाँ से लिखी है मैंने? You have drawn this diagram. OA का जो है वो magnitude हमने यहाँ पे calculate किया है. That I have taken from here. For AB, I will just go here. I will measure this AB vector, multiply with the velocity scale, whatever value you are getting, that I have written in meter per second. For the CB vector, I have measured this CB, multiply with the scale, I have written it here. Now BD, for BD, I have measured this vector BD, multiply this with the scale, multiply it with the scale, and that value I have written here. For slider, I have measured the vector OD, horizontal line, OD, multiplied it with the scale of the velocity, whatever the value what I have written it here. So my velocity column will get filled. All the velocities are known. Now go to the acceleration component. Two components of acceleration, radial or centripetal, and second one is the tangential. The radial component of acceleration is given by velocity square divided by radius of that link or length of that link. So for first link, velocity square means 3.39 square divided by uski length 0.18. How much? 63.84 meter per second square. For second, velocity square divided by this. How much? 2.5. 2.8 square divided by 0.24. 32.66. 10.66. For slider, no radial or tangential component. It got only the acceleration component which is parallel to the line of stroke of that slider. Acceleration will be same as that of velocity. Got it or not? Next, for first link, what is the whether it got the tangential component or not? For first link, this is the question for all. For first link rank, it got the tangential component of acceleration or not? Yes or no? Yes or no? Now first link, as you said, it got the second component of acceleration, that is tangential. How to calculate it? Because they have provided the alpha of first link. Yes or no? How much value? 50 radian per second square. So put that alpha value of AO here, multiplied by radius of that link AO, you will get the tangential component. How much it is? 50 multiplied by 0.18. 9 meter per second square will be the radial component of first link AO, because it is rotating with the increasing speed. It is not constant. So for second link, question mark. Third link, question mark. Fourth link, question mark. Slider, dash. All other question mark, tangential component of all other link you will get after completion of acceleration diagram. Got it? So how to begin for the acceleration diagram? To begin with the acceleration diagram, what you have to do? You have to check the column of acceleration. All the values of acceleration. Minimum value is, maximum value is. So my scale should be such that my minimum value as well as maximum value should be visible on my drawing area. Are you getting? So scale for the acceleration will be 1 centimeter equal to how much? 2.5 भी दिखना चाहिए, 63 भी दिखना चाहिए. अगर मैं 10 लेता हूं तो ये दिखेगा क्या? छोटी लाइन दिखेगी ना, 2.5 mm की. 10 लेता हूं मैं, 1 सेंटीमीटर इक्वल टू 10 मीटर पर सेकंड स्क्वायर. 10 मीटर पर सेकंड स्क्वायर. समझ रहे कि नहीं? सो 2.5 mm की लाइन दिखने वाली है ये, तो मैं उतना ही लेता हूं. 10 लिया तो ये कितना होगा? 6.3 तक जाएगा. इट इज appropriate scale. So my scale is 10 मीटर पर सेकंड स्क्वायर. आपके पास अगर बड़ा शीट है तो आप बड़ी स्केल भी ले सकते हो वहां पे. सुन रहे कि नहीं? So now I am starting for the acceleration diagram. Acceleration, first step in acceleration diagram is what? आप बताओ. What is first step? You have to locate what? Pole. What are the poles? Fixed point of your phase diagram. Which are the fixed point? O and C. Where to locate? In this space. The names are O dash, comma, C dash. Finish. I have located the poles in acceleration diagram. Never change the alphabets. Whatever alphabets you have used in space diagram, same alphabets you have to use. In velocity, small case. In acceleration, with dash. Small case with dash. So, first link. Begin with the first link. How many components of acceleration for OA? 2. First one, always you have to start the acceleration diagram with the radial component. So what is the radial component of OA? What magnitude? 63. By scale, divide this 63.84 by the 10. How much? 6.384, no? That centimeter line I have to draw, but how? The centripetal component is always parallel with what? Parallel with that link. Parallel with that link. Now before that you have to find out where the location of center. तो यानी center कौन होगा? A. My arrow. Don't draw the arrow on your space diagram. It is in your mind. Arrow is going toward the center, but center is moving toward what? Downward direction. कहाँ पे जा रहा है center? Not towards O. I have drawn towards O, but I am reading it as what? So, first acceleration component for this is centripetal. Centripetal is always moves toward what? Center. So center is O, but arrow going towards what? Down or up. So draw the parallel line from either O or A. What is available? What is available? O. The parallel line to OLE in downward direction. You clear it or not? Downward direction, parallel line to OA in downward direction of O. Now this line will be dotted. Why? Why dotted? Because it is the radial component. It is not a net acceleration. If radial component is not there, first line will be dark, which shows the net acceleration of that link. So this line I have drawn for the 6.384 centimeter. Yes or no? So this is the component, so I will put as x dash. I will put as a x dash. Right? So the same link got what? Tangential component, no? Now where tangential component will go? That you have to logic, you have to use your brain. If link is rotating like this, acceleration will go to this direction, no? Yes or no? So draw the tangent line in this direction. What is the magnitude? 9. What is the magnitude? 9. Where your radial component ends, this is the radial of AO. Where your radial component of A ends, there your tangential component begins. Tangential component is always perpendicular to radial component. So draw the tangential component which is exactly perpendicular to this radial. Yes or no? समझ रहे कि नहीं? So this line I have drawn here. सब कुछ बच्चों को क्वेश्चन आएगा. Why not in this direction? मैंने बोला आपको. This is rotating like this, no? So component will move in this direction. So immediately put the name AT. किसका AT? OA. So I have marked radial as well as tangential of first link. Yes or no? Now its net acceleration, where the radial start and where the tangential end. Draw the darker line. That will give you what? Net acceleration of that first link. Net. Total acceleration of that link. Are you getting? I have drawn the radial, I have drawn the tangential, where the radial starts, where the tangential ends. I have joined this by the solid line, and that solid line gives the total acceleration of same link. Yes or no? And this point will be A dash. This point will be A dash. Finish. First link is over. Next link. Which is the next link? AB. Next link is AB. How many components of acceleration? 2. First one? Radial. Which is the center? AB. A is the center. So I am drawing the arrow toward the A. But now I am reading it. Arrow I have shown. This you are not doing on the space diagram. It is back of the mind. Arrow going toward the center. Center is A. But while reading this, where acceleration component is going? Up. Where acceleration component is going? Up. सुन रहे कि नहीं? Yes. Radial component always draw parallel with that link, no? Now from where I have to draw the radial component of AB? Either A or B should be available. Which is available? A. Means the parallel line to AB will be drawn in upward direction from the A dash. From the A dash. Of what magnitude? 2.5 divided by scale. It will come a small line. Small dotted line. Yes or no? Why small? It is less magnitude, no? 2.5 divided by scale. दो 2.5 mm का आएगा लाइन, है ना? Parallel to what? AB. Why upward? Why not downward? Moving up. Centripetal component is moving up. Yes or no? Of what magnitude? 2.5 divided by acceleration scale. That magnitude. Yes or no? Now it got the another component of acceleration or not? What is that? Tangential. Now draw one tangent line to this previous line. Now this is very faint line but dotted. Faint but dotted. Why faint? I don't know where it will cut. सुन रहे कि नहीं? So I will draw this dotted line over. After completing this dotted line for this AB, your AB is over. जब वो कट होगी तब वो पॉइंट मार्क होगा. Next, move to the next link. Which is the next link? CB. How many components of acceleration? 2. How many? 2. First one is radial or centripetal. Radial or which is the center for BC? Always fixed point will be the center. So which is center? Arrow toward the center. Where it goes? Left down. Left down. Yes or no? From where I have to draw this centripetal component of CB. Either C or B should be available. कौन है? C is available. So from C, where is the C? Here is the C. I am drawing what? A centripetal component which is parallel to what? Parallel to किसको parallel है ये? Why downward? Going down, no? Yes or no? So this is centripetal. Of what magnitude? 32.66 divided by scale. 3.26 आएगा. 3.26 आएगा. यहाँ तक निकाल रहा हूँ. This is radial of what? CB, BC. Yes or no? इसको tangent निकालो. Now this tangent is cutting the previous tangent line or not? Previous tangent इसकी. Yes or no? कट हो रही है. जहां पे कट हो रहा है वो पॉइंट होगा मेरा B डैश. क्या होगा? Are you getting? I got the B dash, but resultant acceleration you have to show. Where this radial start? Here. Where the tangential end for BC? Here. Join this C with the B. What is this? Net acceleration of BC, no? Yes or no? Again, where the radial of AB start? Here. Yes or no? Where the tangential ends? Here. So join this by the solid line. A dash B dash. जितने रेडियल है जितने टेंजेंशियल है उसका रिजल्टेंट दिखाना है तभी उस लिंक का नेट एक्सेलरेशन आएगा. Got it or not? Next link. What is the next link? I got the B point, no? BD. कितने कंपोनेंट होंगे? How many components? No. First one radial. Where is the center? BD का center? B. Back of the mind. Arrow going toward the B. But centripetal component going where? Left up. Left up. From where? Either B or D should be available. Which is available? B is available. So BD को parallel line of what magnitude? 10.66 की means 8 सेंटीमीटर की BD को parallel यहाँ से निकलेगी लाइन. कितना होगा मालूम नहीं मुझे. अब ये नाम भी बीच में आ रहा है. This is radial to what? Radial to what? BD, no? Yes. It got the tangential or not? Draw the tangential. This is the tangential. Yes or no? Now कितना निकाला मैंने छोड़ दिया. नेक्स्ट लिंक को जाऊंगा. व्हाट इज नेक्स्ट लिंक? स्लाइडर. स्लाइडर का एक्सेलरेशन कैसे होगा? पैरेलल टू द लाइन ऑफ थ्रो. फ्रॉम वेयर इट विल कम? फ्रॉम द पोल. वेयर इज द पोल? ओ से निकलेगा स्लाइडर के हॉरिजॉन्टल लाइन और प्रीवियस टेंजेंशियल को कट कर रही है. कट कर रही है कि नहीं? दिस विल बी द B dash. Now resultant of BD. Where started? Here. Radial started here. Where the tangential end? Here. Yes or no? join this by the solid line. This line is the net acceleration of BD link. Net acceleration of BD. This is the total acceleration diagram. Now you have kept the question mark here. Tangential component of AD. Tangential component of AD. Which is the radial component of AD? ये है. What is this line? Measure this vector. Multiply with the scale. You will get the magnitude of this in meter per. This value you have to put here. Likewise, all link tangential component you will get from the acceleration diagram.